All right, so let's look at the next section. It says equivalent ratios in higher terms, okay? And this is pretty much like the opposite of what we just did. We reduced it to lowest terms. Sometimes we're going to increase it to higher terms. Let's see why we would do that. Equivalent ratios in higher terms may be obtained by multiplying each term of a ratio by the same number. So for instance, if 3, 2, 1, I can multiply everybody by 3. So 3 times 3 is 9. 3 times 2 is 6. 3 times 1 is 1. See, I didn't disturb the actual ratio between them, the actual relationship between them. All I did was increased it. Just like in these previous steps, I decreased it. That's what he's talking about. So we'll look at some examples in a moment. Higher term ratios are used to eliminate decimals and fractions from the terms of a ratio, okay? So this is why really we are going to use higher terms ratios to eliminate decimals and fractions. Not that decimals and fractions are a bad thing, but sometimes it's difficult to do calculations with them if you don't have a calculator or whatever. So this is why they use this technique, okay? So let's look at the next page. So let's see. Sir, state each of the following ratios in higher terms to eliminate the decimals from the terms of ratios. So this, you can see we got a decimal here, 2.5 ratio 3. So we have to eliminate that. All we have to do is multiply both of them by the same number such that we can eliminate the decimal. Let's say if I multiply 2.5 with 3, I'll get 7.5. Ratio 3 times 3 is 9. 3 times 3 is 9. So I get a ratio of 7.5. Now this is obviously in higher terms than this, but it doesn't solve our problem because the reason we're expressing this in these higher terms is because in the first place we want to eliminate this decimal. So we have to find a different number to multiply it with, such that I can eliminate the decimals. Well, what about if I multiply 2.5 with 2? Well, great. This time I will get 2.5 times 2, 5. Ratio 3 times 2 is 6. So now I have expressed the same relationship here in this higher terms, but with the extra advantage that I have eliminated the decimal, all right? So remember, ratio is ultimately a relationship. We cannot actually change the nature of the relationship. The relationship is saying that for every 5 parts, there's 6 parts, 5 parts of this, there's 6 parts of this, which is the same saying as for 2.5 parts of this, there's 3 parts of this, right? So as long as the ratio relationship isn't disturbed, we can change the actual numbers. So let's look at this one. 1.25 ratio 3.75 ratio 7.5. Again, we have to find such a common number that we can multiply all 3 of them with. Obviously, we can't multiply them with different numbers. I can't multiply this with 2 and multiply this with 3 and multiply this with 5. You know, what I could do that, but then it will upset the entire ratio. It will no longer be the same ratio. It will no longer, because the numbers are no longer being the same ratio, right? So I have to multiply all of them with the same number in order to not disturb the relationship. But the aim for me to still multiply it is to find a way to eliminate these decimals. Now, if I multiply this by 4, I can clearly remove the decimals. So let's say I multiply 1.2 by 4. What is that? That is 5. 1.25 multiplied by 4 equals 5, right? 4 times 1 is 4. Yeah. Ratio, this times 4, this is now 15. Good. And this is going to be 30. So multiply 7.5 by 4 and you get this. Multiply this with 4 and you get this. Okay. Next, again, now we have another term where we're trying to eliminate this fraction from here. So I can see easily there's a 7 underneath. So if I multiply everything with a 7, so I multiply 3 with a 7. 3 times 7 is 21. 3 times 7 is 21. 4 over 7 times 7. 4 over 7 times 7. Remember ratios. This 7 is really 7 over 1. And this will get multiplied, and this will get multiplied. So we will be left with 28 over 7. 28 over 7. And we can just basically divide this at this point, 28 over 7. And we'll get 4, right? 4. So that's what we're left with. You could have easily just canceled this here and you would have been left with a 4. And then finally, 7 times 1. 7 times 1 is just 7, right? So that's what we're left with, 21 ratio 4 ratio 7, which can also be expressed in this form, But the advantage of this form is that we don't have any fraction in it, so it will be easier to further calculate and make changes to this form, right? Ultimately, the relationship is the same because we didn't change anything. We multiplied all of them by the same number, which is 7 in this case, and so we didn't disturb the actual relationship. We just increased it by the same amount. All right. Next, the same thing. Okay, so let's look at it down here. 19.25 over 2.75. Well, all he did was multiply this with 1,000, right? And multiplied this with 1,000. And he's now has 1,925, 275. And then he found a common factor between both of them. Both 1925 and 275 are divisible by 7. Are divisible by 275, and you're left with a ratio of 7 to 1, right? 1925 divided by 275 is 7, and 275 divided by 275 is obviously 1, so we're left with a ratio of 7 to 1, okay? Very good. So this was expressing ratios in higher terms. The last section was expressing in lower terms, okay? Next, allocating according to a ratio. Allocation's problem, and again, if you're not understanding everything, that's fine. We're going to be doing more questions, and you'll see. Allocation according to a ratio. So these are problems we already kind of tackled in the last course as well, so we're going to look at them again here. So allocation problems require dividing a whole into a number of parts according to a ratio. The number of parts into which the whole is divided is the sum of the terms of the ratio. Okay, so what is it saying? Allocation problems require dividing a whole into a number of parts. So you have a whole, okay, and you're dividing it to smaller parts, okay? But you're dividing it according to certain ratio. So like maybe it's 1 ratio 1 ratio 1, you know, and then you're dividing it equal parts, or it's 2 ratio 3 ratio 4. Then one part is smaller than the other parts, right? There's different ways you can cut split something up, and that will be decided by the allocation. How are we told to allocate our resources? So the number of parts into which the whole is divided is the sum of the terms of the ratio. So let's say in this case 21 ratio 4 ratio 7, so it would be 21 plus 4 plus 7. That will give us the total size of the pie, or the metaphorical pie, right? So 21 7 28 32. So out of 32 parts, you know, we're supposed to give 21 to somebody and 4 to somebody else, and then 7 to somebody else. Okay, that's kind of what he's saying. So sorry about that. Okay, so it's kind of fun going all circly like that. All right, so let's go back to our okay, well done. Allocate to $480 in the ratio 5 to 3. So division of 480 in the ratio 5 to 3 may be achieved by dividing the amount of 4 into 5 plus your 8 parts. So basically the value of each term, 480 divided by 8, is 60. So basically, how did we get to 60? First of all, we saw that 5 ratio 3. So the total number of parts are 5 plus 3, which is 8. Now if I divide 480 by 8, which he did, we realize that every part is roughly worth 60 points or whatever, right? So the first term of the ratio gets 5 parts. So the first term of the ratio gets 60 multiplied by 5. And the second one gets 60 multiplied by 3. The first gets 5 and the other 3, right? The first term of the ratio consists in 5 of the 8 parts. That is, the first term 5 multiplied by 60, which is 300. So the first person gets 300. And the second person or whatever gets 180, right? And so 480 to be divided into $300 and $180. Okay, this is similar to a question we did in the last project for last class, where the grandma leaves some money and then has to be split in a certain amount and blah, blah, blah. So when somebody tells you to split $480 in the ratio 5 to 3, all you have to do is 5 plus 3 equals 8, divide 480 by 8 to get the individual part, and then you multiply the individual part with 5 and 3 to get how much each person or vacation is going to get allocated. So in this case, $300 and $180, that's how we're going to split $480. Ultimately, 300 plus 180 is 400, and 300 plus 180 is 480, and this is how we are splitting 480 into these 5 parts and to 3 parts. Okay, well done. So alternatively, 480 in the ratio may be divided by using the fractions. 5 of 8, 5 over 8 multiplied by 3, 480, it equals 300. 3 of 8, 3 over 8 multiplied by 4, 180 equals 180. The same idea, just done a little differently. Anyways, let's keep going. Let's see you guys in the next video.